and welcome to One to Grow On, a show where we dig into questions about agriculture and try to understand how food production impacts us and our world. My name is Hallie Casey, and I studied and am currently working in agriculture.
And I'm Chris Casey, Hallie's dad. Each episode, we pick an area of agriculture or food production that confuses a lot of people and try to get Hallie to explain it to us. This week, we are focusing on worms.
Earthworms! Dad.
Worms.
Dad, you remind me of the worm.
Wait, what?
I said you remind me of the worm.
Why do I remind you of a worm?
No,
or the worm? A particular worm?
You say what worm?
What worm?
The worm with the power.
What power?
The power to...
I have no idea what you're talking about.
It was a David Bowie joke. You remind me of the babe. What babe? The babe
because
with the power.
Of,
but the worm.
Labyrinth?
Yes. So you remind me of the worm. The with the power to transform raw organic matter into humic substance.
Because I poop?
No, it was just a joke. That was all it was.
Okay. So, worms. What's the deal?
Who knows? Honestly, it's pretty confusing.
Okay. I mean, so far as I know, worms are little animals that come out of the ground when it rains, and when you're a kid, you put them on your fish hooks to catch fish. Except for my nephews, who apparently use raw bacon.
What?
Yeah, they were telling me about going fishing with bacon.
With bacon?
With bacon.
I've never heard of that.
Apparently, catfish love it.
Oh, I could see that. That seems like a catfish thing to like is pigs.
I guess.
That's weird. Yeah, so I guess, the first question is, what is a worm? And I thought, naively, going into this episode, that would be kind of an easy lowball. Turns out, no. So, what, to your knowledge, the word worm, what do you think of?
I think of earthworms, the little brown slimy things, like I said, that live in the ground, come out when it rains.
Do you think of anything else in that category of worms?
So there was a movie called, or a series of books and a movie called Dune, which have sandworms in them, and then a movie called Tremors, which had giant sandworms in it. And I remember learning about tapeworm as a kid and thinking maybe I must have had one because I was hungry all the time, but maybe I was just a normal boy.
Yeah, so I don't know anything about giant sandworms in terms of reality. Tapeworms are a real thing. So the way we categorize all living things, right, we have all these different categories. One of them is phylum. It's pretty high up there. It's a pretty broad category. There are 34 phylum total. 15 of them have the word worm in the title of like the English name of it. So one of those phylums is like all vertebrates plus a couple of other things. One is like all of the arthropods and crustaceans, like every bug is just like one of them. And then there's like 15 that are like, looks like a worm. We're going to say that this is a worm.
So there could be different species of worm or different species of animals called worms that aren't really related anyway, except even at the phylum level.
Yeah, except for that they skinny and wiggle. Skinny and wiggle seems to be like the definition of worm. If you're skinny and wiggle, worms.
You have cousins like that.
So historically, the word worm included things like dragons and snakes were all called worms as well.
Okay, yeah, but dragon, it's usually spelled with a Y.
I don't know. That might just be like old-timey English stuff.
That could be. But also dragons, not real. Snakes are real. I guess I could see how they're called worms. That never would have occurred to me, though.
Yeah, no, and I looked at a lot of these different like worm categories. There was some crazy stuff. There was like earthworms, obviously. There was tapeworms. There was something called a penis worm, which is a worm that looks like a penis, I guess. There's a lot of different stuff.
That sounds terrifying.
Yeah, so worms today we are specifically talking about earthworms and excluding any other kind of worm, which includes things like nematodes, which we mentioned in the zoonotics episode, is different from earthworms, but are still, wiggly. So,
and skinny.
Yeah, skinny and wiggly and slimy. So,
what's a nematode?
A nematode is an annelid, I think is how you say it.
What's an annelid?
It's some kind of worm. It's in one of those 15 phylums, and it's just another category of small thing that we just kind of put into the other category.
So today we're talking about
Earthworms.
The brown slimy things
Yes.
that we see on the ground.
Correct.
When it rains,
yes.
or when they're just bored and need to cross the sidewalk.
I guess so, yeah.
All right.
So that's actually an interesting point. I found an interesting piece online that was talking about earthworms and why they come up when it rains. So earthworms get water through their mouth. They have a little mouth, but they have like this slimy little membrane, and they can dry out really easily. So scientists were trying to figure out, why do earthworms come up to the surface when it rains? And they thought that it was something about like the water would flush out their little tube holes in the ground, and they would have to come up so that they didn't get washed away. But turns out it's just faster to not have to dig through soil, and they can just move above the ground and not get dried out when it's raining. So that's currently pervading theory.
Prevailing theory?
Whatever it is, whatever the word is. It is currently what we think is happening.
Tube holes is a scientific term.
No, it's not. What are they called? Like little channels that they dig around?
Tunnels, maybe?
Yeah, tunnels. That's the word, yes.
Okay, we'll go with that.
Worm tunnels. So worms can be all kinds of different sizes. You can get really, really tiny worms. There are some worms that are longer than a foot, which is wild to think about.
So, hang on. When we're talking about earthworms now, in our narrow definition of worms for this episode, is it a genus? Is it a species?
It's a phylum.
It's a phylum.
Straight up.
Whole freaking phylum of earthworms.
Whole freaking phylum.
Holy snapdragons. Holy snap worms.
Worms with a Y.
There you go.
Yeah. These earthworms differ from other earthworms because they are segmented.
Okay.
So usually, like if you're reading about different phylums of kinds of worms, this one's called segmented worms. They don't call them earthworms. So basically this means that there's like different sections of the worm. One end has a brain and like a gizzard and an in hole, and the other side has like an anus and an out hole. You can't cut worms in half. Sometimes if you'll cut a worm in half, the front end will regrow the back end, but the back end's not going to grow a brain. So it's a myth that you can cut worms in half and they'll just continue to live as two separate worms.
So you can't separate the head from the butt.
You cannot.
So you said an anus and an out hole.
Well, I don't know that much. I'm assuming that the anus is the out hole.
Okay.
There's just like a back end, where like it all comes coming out.
There you go.
Yeah, so earthworms eat decaying and dead organic matter. So they eat all kinds of animals. They eat plants. Anything that was alive and is now on its way out is what they eat. And gardeners love these guys.
Okay.
They are kind of up there with bees in terms of like the adorable garden friends that everyone loves.
Wow, that's high praise right there. I always thought it was just because they kept the dirt loose, but it sounds like there's a lot more to it.
Yeah, so I mean, if you think about plants are not really going to be able to take up the nutrients that dead and decaying organic matter is giving off. That organic matter can provide its own benefits to the soil structure, but like if you have a whole dang squirrel or like full tomato plant that died in your ground, then that's not going to be available nutrition. So if you have a lot of worms, they're going to be getting in there and eating it, and then it's going to come out the out hole, very plant available, lots and lots of nutrition and nutrients for the plants to take up.
I thought this was all broken down by bacteria and fungus and stuff.
So lots of stuff is broken down by fungus and other microbes, but worms can work a lot more quickly. And so some of it's broken down by beetles, some of it's broken down by worms, some of it's broken down by fungus, microbes, tons of different stuff is in the soil. The worms work quite quickly. So like if you think of how an ant would break down a leaf, they're going to break it up into small parts, and then it's going to be smaller parts and smaller parts. And it's going to take a very long time for that leaf to turn into what we call humus, which is basically when something is almost exclusively carbon, like it's just organic matter, but it doesn't really look like it was ever something. Like if you think about compost that you buy at the store, that's similar to humus, where it really doesn't look like it was ever anything. It's like fully broken down.
It looks like dirt.
Yeah, yeah. And so a worm can do that pretty quickly. They provide a lot more nutrition, usually a lot more quickly. They've got a quick turnaround time. They're fast workers. They'll break it all up. They also can mix your soil up. So if you have a younger soil, the worms are going up and down and all around. And so they mix that soil up. They bring organic matter from the top of the soil down into the lower layers. It's all kinds of good stuff.
Nice. What if you don't have a lot of worms in your soil? Can you buy worms?
You can, and lots of people do. Lots of people do. A lot of gardeners will bring in worms for their soils. Sometimes even organic farmers will do this. The trick is you have to have the amount of organic matter that's going to support the population that you want. So if you buy a bunch of worms and you don't have a ton of organic matter for them to eat, then a lot of them are going to start dying off.
I mean, I would assume that they would just become organic matter to support the other worms.
They would, very much so, yeah.
Excellent.
Yeah. They also, of course, provide a ton of aeration. I mean, we have some native worms. I think particularly in Australia, they have, I think, 2 or 3 different species of these like massive worms that are like a foot long or longer. And so they provide a ton of aeration. But the small worms do as well. So worms actually have their own tunnels and they will keep using them over and over again. And so they're providing these air passageways. And our soil needs a lot of air, which is not something we often think about. But having these pathways that worms kind of dig provides a lot of air to the soil itself.
Okay, so I have a question.
Yeah.
Is the stuff coming out of the outhole considered manure?
Okay, so that's a good question. So we call that castings.
Castings?
Yes, castings. Worm castings.
When I hear castings, I think of like pouring plaster into something and taking a mold.
I don't know. Honestly, I do not know why we call it that, but that is what we call it.
Alrighty.
We don't call it manure. We call it castings.
Okay.
Yeah, so for a long time, worms have been kind of the signal for how healthy a soil is. Actually, I went to a training earlier this year, and that was one of the things you count. You get down and you like dig up a piece of soil and you count how many worms are in that piece of soil. And that still is, to this day, one of the metrics people use when they're looking at how healthy a soil is. And so when we look at practices like tillage, oftentimes that will reduce your worm count, because if worms have these tunnels that they love to use and your tiller goes in and cuts their tunnels up or even cuts the worms up, then it's a lot harder for the worms to live.
Sounds so sad.
I know.
Poor worms.
So tillage is one of the practices that people point to as worsening soil health. Oftentimes it's tied to worm livelihoods. I guess not livelihoods. That's like being able to buy yourself things. Worms aren't shopping, but like the worms being able to live in the soil.
So maybe this is a little off topic.
Okay.
But why do people till? I assume it's because you have to break up the soil so that it's easy to put seeds in it. Mm-hmm. Otherwise, it's not. But if it's bad for the health of the soil, then what good is it? So
that's a great question. There's still a lot of research being done on no-till production, which is what we call agronomic and horticultural production that doesn't have any tilling.
Okay.
The plow was first invented. I mean, it's arguable when it was invented, but in our Western narrative, we talk about the plow in the prairie lands, the heartland of the U.S. So historically, that area was a lot of long stem prairie grass, which is why we had those huge herds of buffalo go through and kind of graze that grass. So farmers came out and they started tilling that land up because those grasses were so huge that you really had to first pull the grass out and then like break up the soil in order to get to it, right? Because you would have like 12-foot tall blue stem or something like that, or 12-foot tall grasses that were just not, like if you wanted to plant some potatoes in that, like it would not work. So they went in and they started plowing that land, and that made for really fast growing. And that prairie soil had been there for so long, along with the buffalo who were grazing it, that soil was really, really healthy. There were actually no worms in it, which we'll get into in the second half of the show, but it was really, really healthy soil. So when they started tilling, they saw really great production. So you could plant in areas that weren't fully tilled, but they saw that once they started tilling, they were seeing really terrific production because they were getting the grasses out of the way. But over time, that will degrade the soil.
Got it.
Okay, cool. I think that perhaps we should take a break.
One more thing. There's a term on here.
Yes.
Which I don't get. Maybe you went over it and I just missed it, but it's carbon glue.
Oh, yeah, I didn't really touch on that. So one of the things that we think about when we think about soil is the soil's ability to hold itself together. So if you've ever gone out and digged outside of your house, you might know how well the soil will hold itself together. You know, if you can pull something up and all of it is holding together and sticking together, it's a healthier soil or a clayier soil or both, versus if you dig something up and it just kind of all breaks apart and it's very granular, then that might be a sandier soil and or a less healthy soil. So one of the things that helps soil hold itself together is some kind of carbon. And I'm a little bit fuzzy on this. It's kind of a new area of science that I'm still learning a lot about. But basically, if you have higher organic matter and you have more microbial activity and more worm activity, part of what those worms and those microbes are doing is they're putting basically a carbon layer around the outside of what we call a soil pedon, which is kind of like a soil clod, like a clod of soil, like a clump of soil. So they're kind of gluing it together with this carbon. And that carbon is going to help the soil hold itself together and help it infiltrate more water and help all these different things.
Pedon?
Pedon, yes.
Pedon, okay.
Pedon. One word. Pedon.
All right. Well, that sounds pretty cool. I wonder if they're hydrogen bonds holding the soil together. Who knows?
I think they are carbon bonds, but I could be wrong.
Maybe. Okay. Well, speaking of bonding, I think we should do a little father-daughter bonding over the break.
Let's go. Dad, you know who I would always love to go fishing with some bacon and or worms?
I have no idea.
It's our Starfruit patron, Lindsay.
Oh my gosh. Let me tell you guys, she would love fishing so much, especially the worms.
I bet she'd be so good at it too.
She would be great at it.
I also want to give a huge shout out to the wonderful folks over at the Texas Tech University Greenhouse and Gardens.
Which sounds like such a great organization.
Yeah. Hey, guys. Thank you guys so much for listening.
Yeah. Thanks a lot. And thanks for your attention on Facebook and Instagram.
Yes.
And all the places. And also, there is a great podcast that I just learned about and Hallie has known about for a while that I think you'd really enjoy. It's called People Movers. And it's about the impact of escalators on everyday life.
Yeah, it's hosted by Lindsay, who lives in Melbourne, Australia.
She's not Starfruit patron Lindsay.
A different Lindsay with an E, not Lindsay with an A.
But she might like fishing as well.
She's great. She just started the second season a couple of weeks ago. The most recent episode is actually so adorable. It's actually about elevators. It's an interview with a guy who does concerts in elevators around Melbourne. Yeah,
he randomly goes into elevators and starts playing music. And sometimes he gets kicked out. And sometimes people rush to find him. And it was just a really cool, neat episode.
Yeah, we love the show and we would love it if you went and checked it out. We think you'll really enjoy it.
You can follow him on Instagram at People Movers Podcast and listen to him wherever you find podcasts.
Well, should we get back to the episode?
Back to the episode.
Dad, do you have a nature fact for us?
We got 2 nature facts.
What? Unprecedented.
Neither of which are about nature nor facts. Well, maybe one of them's a fact. Okay, so earlier I talked about the movie Tremors.
Okay.
It came out in 1990. I didn't see it at the time because I didn't think it'd be my cup of tea.
Sure.
But I know a lot of people that really enjoyed it and thought it was really great. And so a few months ago, I thought I would check it out. I had some streaming service that happened to have it on. Said, I'm going to watch Tremors. And let me tell you, it was awful. It was so bad. All of these people telling me that it was going to be a great movie were so wrong. So wrong. I hate you all, which is not true. I don't hate you, but I hate your opinion of the movie Tremors because it was a waste of my 2 hours, and I would love that time back. Thank you very much.
Da 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 da. Nature fact.
That's the one. Because it had the giant worms in it.
It did have giant worms in it, as you mentioned earlier in the show.
And bacon.
Did it?
Because it starred Kevin Bacon.
Oh my God. Let's talk about actual worms and not Kevin Bacon anymore.
Okay.
Okay. So, vermiculture.
What?
Vermiculture is
that about vermin?
It is not. It's about worms.
Okay. It's just called vermiculture.
The practice of keeping worms.
Vermiculture is the practice of keeping worms. Why?
Well, I actually did this. I don't know if you remember.
I do not remember.
I did this in college. I had a box of worms in my apartment.
You had a box of what?
Of worms.
Of worms?
Worms. I had worms. Worms. I had worms. For the listener at home, this is actually the first time we've ever recorded an episode in the same room.
That's true. We are in a room together recording this.
We usually do it remotely, and it's a lot of fun to be in the same room.
It's a lot of fun, and it's a whole new dynamic.
Yes. So I had a box of worms in my apartment.
Why?
So for the castings. So the castings are very high in nutrition. So I would take the castings and I would give it to my houseplant.
So this wasn't for a class project. This was just you were keeping worms so you could feed your plant.
Yes. It was like my little pet. My little pet, which I harvested the poop.
Okay. To give it to your other pet if you want to call your plant a pet.
Absolutely, I do.
Okay.
They're not pets. They're my children.
It's good to have priorities. Okay.
Yeah, so people do this on all kinds of scales. Obviously, mine was pretty small. If you want to do it, I can actually, you know what? I'll post a little bit on the Patreon if anyone's interested in keeping worms. It's really easy. It's really fun.
So, but is that really the main reason is for the worm poop?
Absolutely.
The castings?
Yeah,
okay.
Absolutely. And I've seen all kinds of scales. I've seen people have warehouses full of worms from which they harvest the castings because you can market that. They're really, really high in nutrition. And so agriculturally, this is oftentimes what people talk about. Sometimes people have backyard systems, like a little compost system where they'll take their food scraps and they'll put them outside. But usually worms are kind of an indoor compost system because they have to be at the right temperature. And so if they're not in the soil, right, because soil really doesn't change temperature. If you get 3 inches down, it's not really going to change temperature around the year. So keeping them indoors where you can keep them, just not too hot, not too cold, and keep them fed and keep them watered and keep them away from pests. That's oftentimes what we see. And I've seen huge systems and I've seen smaller systems, but yeah. So
there are people that keep giant warehouses of worms to sell the poop.
Correct. Yes, correct.
Wow. Capitalism.
There you go. There's also a system I think it's still being piloted in a couple of developing countries, I think in Southeast Asia mostly, where they are using worms for composting toilets.
What?
So do you know what composting toilet is?
Yeah. I mean, it's a toilet that you use, but you don't flush it. You just kind of leave it there to compost.
And compost, yeah. And the idea is that if you can keep the worms happy and kind of in the right equilibrium where they're not too wet, they're not too dry, not too hot, not too cold, the worms can work a lot faster. And plus, then you get all of this nutrition from your worms and you can scoop the poop away. The worm poop, not the human poop.
And then you don't have to worry about dealing with a septic system.
Exactly, yeah. So this is still being piloted and it would be for, small households. Worms cannot handle a large capacity usually.
Got it. Okay, that makes sense.
Yeah. But yeah, it's currently being piloted, which is pretty cool.
Nice.
We do have, and I mentioned this before the break, something of an earthworm dilemma here in North America.
And why do we have a dilemma?
So worms are not native to North America.
What?
Yeah.
Wait, when and how did they get here?
I mean, they got here when most everything else did, when we had colonialism.
But they're just so everywhere.
Yeah.
And they're so common.
Yes.
And they're so a part of the earth. They just seem like normal things to have in the ground.
Yeah. So there were earthworms in North America, but during the last ice age, they kind of died off and there weren't any anymore. And then when the Europeans came, then they brought earthworms back with them because I don't really know why. maybe they thought it would improve the agriculture. And in some ways it has. But we're having issues now because we have all these huge boreal forests up in Canada that have really, really thick layers of organic matter underneath them, right? Because you don't have much composting them because, I mean, it's cold. So you don't have a lot of fungus and other microbes. And if you don't have worms, then you just kind of build up layers and layers and layers of needles and leaves and bark and all this stuff.
Okay.
So we have these worms that are invasive, that are, in fact, releasing a lot of that carbon.
What do you mean?
So when worms go in and they process this organic material, a lot of it gets turned into worm castings and some of it doesn't. And some of it turns into carbon dioxide.
So they poop and fart.
Well, yeah, most things do, Dad.
Okay. So in the context of these forests, what does that have to do with the worms? They like you had all this organic matter that wasn't decomposing.
Yeah.
But you introduced the worms and the worms are like, oh, hell yeah, buffet.
Exactly.
Okay. And so they start decomposing all the organic matter and that releases carbon into the atmosphere.
Yeah.
Which is bad.
Yes, which was already sequestered.
Okay.
It also actually releases a lot more nutrition into the soil, which can mean that the plant populations could change, right? Because you have these old trees who are kind of used to things the way they are. They don't need a lot of nutrition. But if it becomes a little bit more attractive real estate from plant terms, then you might get invasives or you might get other kinds of plants that are not usually from that region that could push out these old trees.
That definitely sounds bad. Is the carbon sequestration and release not a carbon neutral system? Because wouldn't the trees just soak the carbon dioxide back up?
So I guess what we were looking at in Canada is that the trees were taking in other carbon dioxide, right? Where it's not like we have more trees now that all of this carbon dioxide is being released from the soils.
Okay.
So the trees were taking in carbon dioxide and taking in carbon dioxide and then depositing carbon dioxide on top of the soil that was just staying there. And there really wasn't a lot of carbon coming off of these forests. And now we're seeing drastically more.
Okay. And it's usually, I guess, with something like a big forest, it's usually the reverse.
Yeah, definitely.
Okay.
And it's just because there is just so much built up there and the worms are not from there and they're like just partying. Absolutely.
Yeah. Worm party.
So yeah, I mean, a lot of people love worms. Gardeners love a worm. Like they're very charismatic. Everyone loves their worms. I loved composting with my worms. But yeah, I mean, they are not native to North America. So there's some complexity there for sure.
Wow. So there were worms before. Were they, do we know for sure there was a different species of worm?
I do not know that. Yeah, I did not get that quite that far. And honestly, I don't really understand the speciation of worms.
Okay, fair enough. It all sounded very complicated.
Yeah.
All right. Well, way to worm your way through another episode.
Oh my God.
Unless you have anything else to talk about.
Not really. No, that's the worm stuff.
I guess if we wanted to end on a sort of a final note, have the worms been a net positive or a net negative, or is it just something we have to think about both sides?
I do not know the answer to that. I think that's a really good question, but it's so hard to answer.
Okay.
Because one, I mean, we're still learning the extent to which this is going to be adding carbon back into our atmosphere, right? We're still trying to understand what that impact is going to be of this worm party happening in Canada right now. But on the other side of that, there are all these economic benefits that are so hard to quantify that have happened over the past, what is it, like 400 years, right? So it's just one of those questions that I think is so hard and is so nuanced. And the answer is really like, it depends who you ask and what the final impacts are going to be. And there might even be other impacts that we don't know, like worms might be decimating a microbial population that we can't even tell yet because we haven't identified so many microbes. You know, there's so many microbes out there that we don't even know what they're doing or how they're living, you know, how they're interacting in the soil. There's so many more questions. The worms aren't going anywhere, right? So it's kind of a question about how are we gonna fix this, or not fix it, but how are we going to address climate change? At the end of the day is kind of the question, which is always the question at the end of the day.
It's true, especially when it's as freaking hot as it is.
Yeah. All right, that's the end.
That's the end. Thanks for listening to this episode of One to Grow On.
This show is hosted by me, Hallie Casey, and Chris Casey.
It is produced by Catherine RJ and Hallie Casey.
Our music is Something Elated by Broke for Free.
Connect with us on Twitter, Instagram, and Facebook at onetogrowonpod.
You can find all of our episodes as well as more information about the show and the team on our website, onetogrowonpod.com.
Join our community and learn more about each episode at patreon.com/onetogrowonpod. There you can get access to audio extras, fascinating follow-ups, and even custom art created just for you.
If you like the show, please share it with your friends. Sharing is the best way to help us reach more ears.
Be sure to check out the next episode in 2 weeks.
But until then, keep on growing.
Bye, everybody.